Today, Class 7 Greenhouse Effect and Global Warming. Greenhouse Effect and Global Warming. A greenhouse is a structure whose roof and walls are made chiefly of transparent material such as glass, in which plants requiring regulated climatic conditions are grown. In a greenhouse, the incident solar radiation, the visible and adjacent portions of the infrared and ultraviolet ranges of the spectrum, passes through the glass roof and walls and is observed by the floor, earth and the contents, which become warmer and remit the energy as longer wavelength infrared radiation. Heat radiation. Glass, glass and other materials used for greenhouse walls do not transmit infrared radiation, so the infrared cannot escape via radiative transfer. As the structure is not open to the atmosphere, heat also cannot escape via convection, so the temperature inside the greenhouse rises. This is known as the greenhouse effect. Importance of greenhouse effect. The greenhouse effect is a natural phenomenon and has been occurring for millions of years on the earth. Life on the earth has been possible because of this natural greenhouse effect, which is due to water vapor and small particles of water present in the atmosphere. Together, these produce more than 95% of total greenhouse warming. Average global temperatures are maintained at above 15 degrees centigrade due to natural greenhouse effect. Without this phenomenon, average global temperature might have been around minus 17 degrees centigrade, and at such low temperature life would not be able to exist. Greenhouse gases, GHGs. Yes. Atmospheric gases like carbon dioxide, methane, nitrous oxide, water vapor and chlorofluorocarbons are capable of trapping the outgoing infrared radiation from the Earth's surface, thereby causing greenhouse effect. Hence, these gases are known as greenhouse gases, and the heating effect is known as greenhouse effect. Oxides of nitrogen with general formula NOx, NO, NO2, nitrogen oxide, nitrogen dioxide, etc. are global cooling gases, while nitrous oxide is a greenhouse gas. Ozone layer. The ozone layer is a region in the Earth's stratosphere that contains high concentration of ozone and protects the Earth from the harmful ultraviolet radiations of the sun. Ozone layer depletion. Ozone layer depletion is the thinning of the ozone layer present in the upper atmosphere. This happens when the chlorine and bromine atoms in the atmosphere come in contact with the ozone and destroy the ozone molecules. One chlorine can destroy 1 lakh molecules of ozone. It is destroyed more quickly than it is created. Some compounds release chromine and bromine on exposure to high ultraviolet light, which then contributes to the ozone layer depletion. Such compounds are known as ozone depleting substance, ODS. Causes of ozone layer depletion. The ozone layer depletion is a major concern and is associated with several factors. The main cause responsible for the depletion of ozone layer are listed below. Chlorofluorocarbons. Chlorofluorocarbons or CFCs are the main cause of ozone layer depletion. These are released by solvents, spray aerosols, refrigerators, air conditioners, etc. The molecules of fluorocarbons in the stratosphere are broken down by the ultraviolet radiations and release chlorine atoms. These atoms react with ozone and destroy it. Unregulated rocket launches. Research says that the unregulated launching of rockets results in much more depletion of ozone layer than the CFCs do. If not controlled, this might result in a huge loss of ozone layer by the year 2050. Nitrogenous compounds. The nitrogenous compounds such as NO2, NO, N2O are highly responsible for the depletion of ozone layer. Next, natural causes. The ozone layer has been found to be depleted by certain natural processes such as sunspots and stratospheric winds, but it does not cause more than 1 to 2% of the ozone layer depletion. The volcanic eruptions are also responsible for the depletion of ozone layer. Effects of ozone layer depletion. The depletion of the ozone layer has harmful effects on the environment. Let us see the major effects of ozone layer depletion on men and environment. Effects on human health. The humans will directly exposed to the harmful ultraviolet radiations of the sun due to the depletion of ozone layer. This might result in serious health issues among humans such as skin diseases, cancer, sunburns, cataract, quick aging, and weakened immune system. Effects on animals. Direct exposure to the ultraviolet radiation lead to skin and eye cancer in animals. Effects on the environment. Strong ultraviolet rays may lead to minimal growth, flowering, and photosynthesis in plants. The forests also have to bear the harmful effects of the ultraviolet rays. Effects on marine life. Planktons are greatly affected by the exposure to harmful ultraviolet rays. These are higher in the aquatic food chain. If the planktons are destroyed, the organisms present in the lower food chain are also affected. Solutions to ozone layer depletion. The depletion of ozone layer is a serious issue, and various programs have been launched by the government of various countries to prevent it. However, steps should be taken at the individual level as well to prevent the depletion of the ozone layer. Following are some points that would help in preventing this problem at a global level. Avoid using pesticides. Natural methods should be implemented to get rid of pests and weeds instead of using chemicals. One can use eco-friendly chemicals to remove the pests or remove the weeds manually. Minimize the use of vehicles. The vehicles emit a large amount of greenhouse gases that lead to global warming as well as ozone depletion. Therefore, the use of vehicles should be minimized as much as possible. Use eco-friendly cleaning products. Most of the cleaning products have chlorine and bromine releasing chemicals that find a way into the atmosphere and affect the ozone layer. These should be substituted with natural products to protect the environment. Use of nitrous oxide should be prohibited. The government should take the actions and prohibit the use of nitrous oxide that is adversely affecting the ozone layer. People should be made aware of the harmful effects of nitrous oxide and the products emitting the gas so that its use is minimized at the individual level as well. Global warming. Global warming is the long-term heating of Earth's climate system observed since the pre-industrial period between 1850 and 1900 due to human activities, primarily fossil fuel burning, which increases heat trapping greenhouse gas levels in Earth's atmosphere. Causes of global warming. Burning fossil fuels. When we burn fossil fuels like coal and gas to create electricity or power our cars, we release carbon dioxide pollution into the atmosphere. Deforestation and tree clearing. Plants and trees play an important role in regulating the climate because they absorb carbon dioxide from the air and release oxygen back into it. Forests and bushland act as carbon sinks and are valuable means of keeping global warming to 1.5 degrees centigrade. But humans clear vast areas of vegetation around the world for farming, urban and infrastructure development, so to sell tree products such as timber and palm oil. When vegetation is removed or burnt, the stored carbon is released back into atmosphere as carbon dioxide, contributing to global warming. Agriculture and farming. Animals, livestock like sheep, cattle produce methane, a greenhouse gas. When livestock graze at a large scale, as in Australia, the amount of the methane produced is a big contributor to global warming. Some that farmers use also release nitrous oxide, which is another greenhouse gas. Impact of global warming on agriculture. Global warming affects agriculture in a number of ways through changes in average temperature, rainfall, and climate extremities. Example, heat waves, changes in pests and diseases, changes in atmospheric carbon dioxide concentrations, changes in the nutritional quality of some foods, and changes in sea level. Agriculture is a larger share of developing economies than of industrial economies. It has been widely accepted The developing countries in general will be more affected from the global warming impacts on agriculture than developed countries. This is because of less adaptability of developing countries to the changing situations than the developed ones. Most are in warmer parts of the globe where temperatures are already close to or beyond thresholds at which further warming will reduce rather than increase agriculture outputs. Pests, insects, and climate change. Global warming could lead to an increase in insect pest population, impairing yields of staple crops like wheat and soybeans. As warmer temperatures are conducive for pests, it increases the metabolic rate and number of breeding cycles of insects, causing a population boom. Changing precipitation patterns. Rainfall patterns have already begun shifting across the continent, and such changes are expected to intensify over the coming years. In that case, we are likely to witness more intense stretch of heavy rain and longer dry spells even within the same region. Changing temperature patterns. Rising average temperature, severe heat throughout the year, fewer cool days during the winter, and more frequent cold season thaws will likely affect farmers in all regions of the world. No food security. Climate change affects crops by impacting irrigation, insulation, as well as the prevalence of pests. Increased frequencies of droughts, floods, storms, and cyclones are likely to increase agriculture production variability. In the long run, climatic change could affect agriculture in several ways. By inducing more extreme weather such as floods, droughts, and storms, by changing overall growing conditions, general rainfall distribution, temperature regime, change in productivity as a whole in terms of quantity and quality of crops, change in agriculture practices through changes in irrigation patterns and agriculture inputs such as herbicides, insecticides, and fertilizers. Environmental effects related to soil drainage, leading to nitrogen leaching and soil erosion. Forced development of more competitive organisms such as flood resistant or salt resistant varieties of cereal crops like rice. Minimizing effects of climate change, crop diversification, and breeding more enduring crop varieties, using improved agroforestry species and native perennial crops to create a diverse agro ecosystem, collection and conserving rainwater and use of improved irrigation practices, increasing forest cover, planting covers crops, and deep-rooted perennials that increases water holding capacity of soil to soak up heavy rainfall and retain water for dry periods. Use of latest water harvesting techniques such as contour trenching. Next, carbon sequestration. Carbon sequestration is the process of capturing and storing atmospheric carbon dioxide. It is one of the methods of reducing the amount of carbon dioxide in the atmosphere with the goal of reducing global climate change. Cropping system and agronomic practices that can be helpful in carbon sequestration. First, crop rotation can improve biomass production and soil sequestration, especially rotation with legumes and non-legumes. Growing legumes can subsequently reduce the nitrogen input as chemical fertilizer, which in turn can reduce the fossil fuel consumption in manufacturing fertilizers. Increase in cropping intensity or cropping more frequently by reducing the frequency of bare land fallow in the crop rotation is another effective approach to improve biomass production and soil carbon sequestration. Next, intercropping. Intercropping can improve the crop productivity due to increased efficiency of utilization of sunlight with an adequate spatial distribution of various plant architectures. Intercropping systems include row crop intercropping, strip intercropping, mixed cropping, and relay intercropping. A strip cropping systems with oats, corn, and soybeans or ridge till rows showed that net returns while strip intercropping can be increased by 38% compared with same crops in monoculture. With these mutual benefits, an overall optimal productivity with corresponding quantity of biomass of both underground and above ground can be reached, which shows a potential for biomass return and soil carbon sequestration. Next, cover cropping. Growing cover crops is another effective approach to improve carbon sequestration and associated storage. In the temperate region, water cover crops such as ryegrass, oats, pea, wheat, clover are commonly grown in fall and survived through the mild winters and grow again in spring to cover the bare lands during the off season. Companion cropping. In organic farming for vegetable production system, companion cropping system is often practiced. For example, the use of permanent beds of companion crops grown alongside the vegetable crops, example lettuce and cabbage, etc., has been developed under various conditions, which is perceived as a possible alternative in organic crop production. Trapping effects. An excellent example is the use of collards to attract the diamond black moth away from the cabbage because the former plant is more attractive to the pests. Next, biochemical pest suppression. Some plants exude chemicals from roots or aerial parts that can suppress or repel pests and protect the neighboring plants. For instance, the African marigold, which can release thiopine, a nematode repellent, making it a good companion for number of garden crops. Nursing effects. Tall and dense canopied plants may protect more vulnerable species through necessary shading. Example, ginger plant, or by providing windbreak. For instance, oats have been long used to help the establishment of alfalfa and other forages. Ratoon cropping. Ratoon cropping is a technique allowing a crop to produce two or more harvests for yield from one planting. The basic requirement in ratoon cropping are that the crop has to have a well-developed root system, earlier maturity, and a perennial nature. Ratoon cropping has obvious advantage for crop production and soil carbon sequestration. Cropping practices. Appropriate cropping practices such as fertilization to adjust nutrient balance, appropriate water supply, etc., are important factors to optimize biomass production, improve crop growth and development. Therefore, to enhance carbon sequestration in the soil, increased amount of plant residues must be returned to the soil and the soil must be kept a minimum disturbance. Benefits of soil carbon sequestration include the following. Agriculture sector can be supportive in the lessening of emissions of GHs, and if suitable agronomical practices are to be adopted, then agricultural soils have the potential to act as a sink for carbon dioxide sequestration. Healthy soils can be supportive in combating the climate change because soils having high organic matters can have higher carbon sequestration potential. El Nino effect, its causes and its impact on Indian agriculture. El Nino is a climate pattern that describes the unusual warming of surface waters in the eastern tropical Pacific Ocean. El Nino facilitates the movement of monsoon winds from the sea to the Indian land without any significant diversion. Causes and its impact on Indian agriculture. Off the coast of Peru, there is normally cool surface water because of the cold Peruvian current, but El Nino makes it go warm. When the water becomes warm, the trend winds, which otherwise flow from east to west, either reverse their direction or get lost. Due to this warm water, the air gets up and surface air pressure above eastern Pacific gets down. On the other hand, the water cools off in western Pacific and off Asia. This leads to rise in surface pressure over the Indian Ocean, Indonesia and Australia. Now, as the pressure over the Peruvian coast reduces because of the warm seawater, the flow of moisture-laden winds is directed to the Peruvian coast from the western Pacific. Hence, the moisture-laden winds that should have moved towards the Indian coast now move towards the Peruvian coast. The warm water causes a lot of clouds getting formed in that area, causing heavy rains in Peruvian desert during El Nino years. This robs the Indian subcontinent of its share in the monsoon rains. The greater the temperature and the pressure difference, the greater would be the shortage in the rainfall in India. Impact of El Nino. Drought or scant rainfall Pacific Asia. This leads to in Western a lot of undesirable circumstances. In India, almost 50% of area under cultivation is rain-fed. Indian agriculture is thus heavily dependent on the climate of India. A favorable southwest summer monsoon is critical in securing water for irrigation in Indian crops. So, a significant reduction in total rainfall results in a drought-like situation. Drought in India have resulted in 10 of millions of deaths over the course of the 18th, 19th and the 20th centuries. In some parts of India, the failure of the monsoons results in water shortages, resulting in below average crop yields. This is particularly true of major drought prone regions such as southern and eastern Maharashtra, northern Karnataka, Andhra Pradesh, Odisha, Gujarat, and Rajasthan. A lot of farmers suicide because they are not able to repay the loan they had taken for growing the crop. Shortages in food supply then results in spike in food prices all across the country, pushing inflation up. High food inflation eats into other sectors too, such as food processing sector. If the drought is severe, it would dry up major sources of fresh water, leading to a water crisis like situation. The groundwater level will also go down. This would not afford not only affect supply of drinking water but also supplies of water into the canals and hand pumps for agriculture irrigation. Weak monsoons also result in lesser power generation from hydro power dams, thus leading to even lesser electricity for irrigation purposes. This further reduces the crop yield. Another important source of income for the farmers is livestock and the fisheries. Both are affected severely by the drought.